Hello. In this problem, we are looking at the college enrollment in public colleges in the U.S. We're looking at some older data prior to 2008 because in 2008 we had in the U.S. what was called the Great Recession, which reset a lot of trends. And so we had a nice trend going prior to 2008. So as I'm looking here, it first asks me to look at the change in y values. So we know that change in y is like the beginning of slope. And so for the first change in y from 0 to 1, I would take 13.02 and I would subtract 12.98. And so when I do that math, I have a change of 0.04. It also asks me to look at the y ratio. So this is where I take the y2 value, the 13.02, and I divide it by the 12.98. And when I write that out to two decimal places, I have 1.00. And then we're going to continue doing that for all of the others. So from 1 to 2, I'm going to take 13.18 minus the 13.02, and that gives me 0.16. And I'm going to do the ratio as well. And so that would be the 13.18 divided by 13.02, and to two decimal places, that gave me 1.01. So if you'd like to, at this point, you can pause the video and complete the rest of these. I'm going to go to my next slide where I type these in. So I have completed all of the change values and I've completed all of the ratios. And then it asks me here to discuss observations. So the first observation I have is that the change is not constant. My second observation is that the ratios are also not constant. And so it's hard to draw a conclusion because neither one is constant. And because these are not constant, I can decide that it's not exactly linear, because linear would be constant change, which I don't have. And I can also decide that it's not exactly exponential. Because exponential would be a constant ratio, and I don't have that either. So that's what I've observed. It now asks me to plot the data points, and this is really what I want to focus on in this video, is how to plot these data points. So before I go to my graphing calculator, I noticed that we're to use X for years since 2004. So my X values are the 0, 1, 2, 3, 4. And then my enrollment is the Y values, and those are given here as well. So I'm going to go over to my graphing calculator. I'm going to go into my data. So in order to do that, I'm going to hit Stat. And then I'm going to hit Enter to edit. I want to clear out my last problem, so I'm going to arrow up to where it says the name, list 2, hit Clear, and Enter. I'm going to go over and do the same thing, so up to the name for list 1, hit Clear, and Enter. Now I'm going to type my X's into list 1. So they were 0, 1, 2, 3, and 4. And then I'm going to type my enrollment numbers into list 2. And so I do have these on paper in front of me, even though you can't see them, but you can type along. So the first enrollment was 12.98. Arrow down. Then I have 13.02. Next, I had 13.18. Next, I have 13.49. And finally, I had 13.97. So I want to see these on the coordinate plane. So I'm going to go into my y equals. I'm going to clear out whatever I have in there from before. And I'm going to make sure that my first plot is turned on. So I'm going to arrow up and hit enter to turn that plot on. Now, we've already set up our plots here in class, but if you need to set up your plot, you can hit second y equals for stat plot. You'll notice that plot 1 is turned on. You'll notice that plot 1 is using list 1 and 2. It's creating a scatter plot, and I can check all that if I hit enter here. So I want it on. I want the first type, the scatter plot, the points. I want it to use list 1 and 2. And I usually pick this first mark, the square, because that's easiest to see on my graph. If you have the color calculator, you could choose color as well, and I'm going to let that as the default. So that's how I would turn that on. Once I set that up once, though, it is set up. And so from there, I can always just go to my y equals, and if my box is dark around the plot, my plot's on. And so here I see plot 1 is on, plots 2 and 3 are off. Next, I want to set up my window, and my window is actually a little easier to set up than when I have an equation. So when I want to set up my window, the x values that we typed went from 0 to 4. The y values that we typed, our smallest one was 12.98, so I'm going to go a little smaller than that, so let's go 12.5. And my largest one was 13.97, so I'll go just a tick larger than that at 14. And there's lots of flexibility, so you might have went up to 15 or down to 12, up to you. And so I'll hit graph, and I see the dots. So these are the points that I'm looking at. And let's take a look at our questions from here. So it asks us, plot the data points. Check, we just did that. It says, does it look reasonable to approximate this data with a straight line? So let me go back and look at my graph. I feel like I want a little more space around my graph, so I'm going to go and change my window. So I'm going to make it go out to 6 so that I could just go a little bigger. I'm going to make it go down to 12, up to 15. And you can play with this until you see a little bit better picture, whatever you want it to be. Okay, now I have a little more space. And so I'm just using my stylus here and sketching, and they're kind of on a straight line. It does seem like there could be a little bit of a curve to them, but especially the last 3 really look like they're on a straight line, or maybe the last 4 points. And the first point is a little off from the others. So to answer my question, I think it might be it's an approximation. It's definitely not exact. But we could approximate. So then it asked me to find the regression equation, and it asked me to graph it in the same window. So this is some calculator work. So to find the equation, I start with stat, and I arrow over to the calculate menu, and I'm choosing option 4 because I want to approximate it with a line, because I said that might approximate it. It's not perfect. Hit enter. And again, you should be able to enter directly through these. It's set up to use list 1 and 2, which is where we put our data. And then I'm not going to worry about storing it. I'll just calculate it. So from that, I see that the A here is in the position of slope, so 0.245, and the B is in the position of the y-intercept. So I'm going to go to my y equals, and I'm going to type this in. So 0.245x plus 12.838. And I'm going to hit graph. And so this is the best fit line. So the graphing calculator has a calculus process programmed into it to find the fit, the one line that is closest to all of the points. And so we see that 0.2 and 0.3 it's real close to, and the others it gives an approximation, definitely not exact. So looking back at our questions, so we found our equation, we graphed it in the same window, check those. We're to explain the meaning of slope. So our slope was 0.245. and it's positive. So, and we're talking about enrollment up here. So I would say enrollment increases by 0.245, borrowing a word from over here, this word million, by 0.245 million each year. Now, because our line just approximated it, I might want to put that word in my sentence. So enrollment increased by about 0.245 million, because it definitely is not exact. It did not have a constant rate of change. And so putting a word in there to express that it's not exactly right on can be helpful. Next, it asks us to express using function notation the enrollment in 2003. So in 2003, looking at my numbering, that would be the year before 2004. 2004 was year 0, so 2003 would be year -1. And then it also asked me to look up 2014. So again, just looking this through, so 2014. So what year would be 2014? Well, 2004 was year 0, so 2014 would be 10 years later. So this would be year 10. So I'm going to look them up in my table. And so let's go to our calculator. So second, table setup, starter table at 0, go up by 1, that works. Table, so if I arrow up, I see for 2003, which is this -1, I had 12.593. So I'm going to write that down before I forget it, and then I'll look up the next one. So 12.953 or 593. All right, and then 2014 we said would be year 10. So scrolling in my table to 10, 15.288. So 15.288. And then it asks, well, it gives us. So we found the value, that's a check mark. Oh, it says use function notation. So let me do that. So this is equal to f of -1. That's what I looked up. This one's equal to f of 10. So we've got that function notation in there. Actual enrollment for 2003 was 12.86. Did your equation give you a good estimate? It's an okay estimate. It's close, but it's not exact. But it was only asking about an estimate. What about 2014? Here we're off by quite a lot in millions. So did it give a good estimate? Not really. Off by a good bit. So there's no hard fast, this is a good estimate, this is not, it's your opinion. The closer it is, the better estimate it is. The closer the number you're looking up is to the actual data, the better the estimate should be. So we are expecting a pretty good estimate for 2003, 1 year before our data set. And 10 years after our data started at 2014, and knowing that there was economic recession in 2008, I'm not expecting a great estimate, and I don't really get a good estimate. And the reason why we talk about this at all is so that you're an intelligent consumer of information. So if people are predicting things for a bit in the future, it's probably a good estimate. If people are predicting things way in the future, it's probably not a good estimate because so much can happen in between. So I hope that from this video, you pick up on some key things. And that is when we don't have constant change and we don't have constant ratios, it's not going to be exactly linear or exactly exponential. So in those scenarios, we can use our calculator to find this regression equation, which is an estimation line. And so sometimes those estimations are better, sometimes they're worse, but they are always just estimates. And we're using our calculator to get that best fit line, not doing that one by hand.